Okay, so what we're going to talk about is it's called special cases, and it's not that impressive of a topic, but it is at the very least it's interesting. So let's go with again. This section is or this chapter is concerned about graphing rational functions. And so let's say we are faced with graphing the following function. Uh, 2x squared minus 7x minus 4 divided by 2x squared plus 5x plus 2. Again, with this, you're thinking to yourself, oh shoot, what am I going to do? Previously, you would have had to factor the bottom. And then, well, now you've got a quadratic on the top as well. So what we'll want to do is factor both of them, all right? So it's 2x plus 1, x minus 4, 2x plus 1, and x plus 2. That would be the factorization. And now you would notice, well, look, these are like factors, and because one of them is in the numerator and one of them is in the denominator, and there's no addition or subtraction in between this factor and its neighbor, then you can cancel them because they are factors, not terms, basically. And so you have that. But then you have to think to yourself, well, wait a minute, in the original function, x cannot equal 1/2 or 2. Alright? X cannot equal 1/2 or 2. But now that you've canceled these, what you actually have is x minus 4 and x plus 2. And if you want to try and graph this is a pretty easy one to graph, because you know that it's a rational function of the form a, b, c, d, where a is 1, b is -4, c is 1, and d is 2. And now you can find the horizontal asymptotes, the vertical asymptote, the x-intercept and y-intercept, and you can graph this, all right? But the one thing you have to do is you have to keep in mind these restrictions, all right? So what we're going to do is we're going to graph this function right here, and like I said, just keep in mind this stuff over here, okay? And so we know that the y-intercept is a -4 over 2, or a b over d. Y-intercept is a b over d, or a -4 over 2, or a -2. We know that the vertical asymptote is a -d over c. That's a -d over c, or a 2 over 1, a -2 over 1. So the vertical asymptote is also 2. The horizontal asymptote is an a over c, okay? Remember, these are our numbers here. And finally, the last bit is, what is it? We did x-intercepts now. And the x-intercept is going to be, let's see, a negative b over a. So a negative 4 over 1, or a positive 4. And now with that information, look at all that. I can make a pretty nice graph of this thing. Alright, so we'll go with, we've got 4s and 2s here. 1, 2, 3, 4. 1, 2, 3, 4. 4. 1, 2, 3, 4. We'll go a little extra here. Okay. So I got a vertical asymptote at negative 2. I've got a horizontal asymptote at 1. An x-intercept at 4 and a y-intercept at negative 2. It must be that my my restrictions up here are negative 2 and negative 1/2. I totally forgot my negatives way up there. We'll talk about that. So, there we go, made that graph, and bang, made that one as well. So it looks basically something like that. I did a pretty poor job going through the y-intercept there. But what we now have to look at is x can't be negative 2. Well, we got that already. This is the asymptote because that's the one that didn't get canceled. It's the factor that didn't get canceled in the denominator. Remember this factor up here, way up here, that got canceled? Well, that makes it, that because that factor existed in the original function, it makes it so that x cannot equal negative 1/2. Negative 1/2. And so what we have to do here is we actually have to go to negative 1/2 and put what's called a hole in the graph. And that's basically the idea. And so that would indicate to everybody that, hey, there was a factor up before that's got that's probably looked something like positive 2x plus 1 that must have gotten canceled out in the original function. Alright? So that's basically the graph of this. So there's a few special cases. Just look for something that will cancel, and then if it does, you end up with a hole in the graph. Okay? And that closes up the chapter 3.